This is the introduction to square root equations. Today's equations, we're going to try to get the square root isolated and then square both sides. So those are the steps. Some of them are very basic equations like this, where your square root is just a single item. So let's go ahead and get the square root isolated by moving everything else away. And that gives us the square root of x is equal to 14. What this means is there's something I can take the square root of that's going to equal 14. So to undo this process, you square both sides. And so x is equal to 196. And you can check this by plugging it back into the original equation. The square root of 196 minus 4 should equal 10. And if you ever get this to not work and it is an actual plug-in, everything else in your work works, it could be extraneous solution. We will not have any extraneous today. We'll get into those later. Let's look at this next one. So this whole thing is what we are trying to isolate. If you want to think of it like we did the smiley faces earlier this year, well, that's your smiley face and you're solving for it first, and then you take things out of it, that might not be a bad idea for some of you. So let's get that square root of 3n plus 16 by itself first. Well, what's on the side that doesn't belong? This plus 9. So we need to move the addition of the 9 to the other side. So we need to subtract 9 to both sides. And that's going to give us the square root of 3n plus 16 is equal to 1. Now my square root is by itself, so the next step is to square both sides. And so 3n plus 16 is equal to 1 squared, which is 1. Because when you square a square root, it takes the square root away and just gives you what's inside. Now, we need to solve for n. So we just like we would normally solve an equation. Subtract 16. And we end up with 3n is equal to a negative 15. Now we're going to divide both sides by 3. And n is equal to a negative 5. So if I go back up here and I plug that back in, 3 times negative 5 plus 16. Take the square root of that and then add 9. I should end up back at 10. So that's negative 15 plus 16. So that's going to give me a 1 under that square root. The square root of 1 plus 9 is 10. So that does work out. So in this one, we have a 4 being multiplied times your square root, and then we're going to add a 2 at the end. So to get this isolated, you have to think through what operations would we undo first when we're solving equations. Well, the first thing you're going to undo is the addition and subtraction. And so we're subtracting 2 from both sides. And we have 4 times the square root of 2x minus 3 is equal to 12. The next thing that we are going to undo is the multiplication. So we're going to divide both sides by 4. And so we have the square root of 2x minus 3 is equal to 3. Now, my square root is by itself, so I'm going to square both sides. And so when I square a square root, what is under it comes out. So that gives me 2x minus 3. And 3 squared is 9. Now I'm going to solve this equation. Add 3. 2x is equal to 12, divide by 2, and x is equal to 6. This one looks a little bit different, but it's asking us to solve this set of equations. So it's asking us, where do these two lines intersect? So going back to the way we did systems, we can use substitution method and set this equation equal to this, because they're both equal to y. So all I'm going to do is take sides that are different and set them equal to each other. So I'm going to set the square root of x squared plus 6 or minus 16 is equal to 3. Is my square root by itself? Yes. So all I need to do is square both sides. And so that brings what's under my square root out, giving me x squared minus 16 is equal to 3 squared, which is 9. Add 16 to both sides. And we have x squared is equal to 25. So what this is asking me is, what number can I multiply times itself to get me 25? Well, that means to solve this, I need to take the square root. And that's 5, because 5 times 5 is 25. But it's also a negative 5, because a negative 5 times negative 5 is 25. So this one has 2 solutions. And so let's go back and check it and see if both solutions work. So if I was to check the positive 5 squared minus 16, I'm just curious what number that comes up with. So that's going to be the square root of 25 minus 16, which is the square root of 9, which is equal to 3. Does that check out to what my original equation was? Yes. Now let's check the other one. Let's check and see what happens if I have a negative 5. I'm squaring minus 16. Well, negative 5 times negative 5 is 25. So at this point, I can see that I am not getting any different numbers, and so I didn't have to go any further. So that does equal, so these both work out. So they are both solutions. Let's work one last problem. I'm going to subtract 12 from both sides. And I end up with a square root of 2x minus 7 is equal to negative 5. This is one that's going to have no solution. If you get your square root isolated and it's equal to a negative number, it is no solution every single time. You don't have to go any further. So if you get your square root isolated and it's equal to a negative number, it is no solution every single time.